chapter, and it has to do with corrosion prohibition. Okay, and this it doesn't have any numbers in it. This is much more definitional, but much more applicable to everyday life. Corrosion, by definition, is the oxidation of a metal to produce a variety of compounds of the element through interaction with the environment. We call that rust, and in some cases, if the rust is pretty, we call it a patina or a patina. It depends upon, tomato, which way you want to pronounce it. But this is a major problem, corrosion, because think about it. If you leave metal out in the weather, so you have a very ornate steel gate, then if you don't do something, it's going to corrode. And your car, this is really important on cars because in the north, they have a lot of cold weather, so they salt the roads. We don't have that in the south, so you have to be careful because the people have learned that you may not be able to sell it in the north because they look underneath the carriage, but in the south, we're not used to doing that. So a lot of times, that's the latest thing is used cars, be careful, look underneath, because it's real easy to get a rust spot. And a lot of times if you see a rust spot, it'll be in a perfect circle. And that is because water will act as a catalyst to help transfer the electrons at the edges. So hence you end up with the rust around in a perfect circle. So it's kind of protected here, etc. But the water droplet really helps in the transfer. And if you'll see that when you run this reaction, you have a very large, very positive E cell. So this is a very spontaneous reaction. And it is a major problem because ships do not like to rust. And pipes in refineries, different factories, whatever, really can't rust because then you have problems, etc. So rusting is a major issue that needs to be dealt with. Now, this is actually kind of a cool slide because this shows you that as the reduction occurs, this is agar-plated out with phenolphthalein. And so you get the formation of the pink area where the rust is occurring because the oxygen is reduced to the hydroxide. Anyway, that's just a cool slide. So how do you protect against corrosion? Well, there are 3 ways. The first and the easiest way is to do some sort of coating. Now, a most common, if you're dealing with metals, etc., like if you're making a deck, building a deck, or building outside your house, you want galvanized screws. Well, galvanization is simply coating the metal with a thin layer of zinc. And everybody's seen galvanized buckets. They stay pretty and shiny for a long time, but if you scratch them, then they'll rust underneath. Okay, the other thing that you can do is just put a plastic coating on it or a coating of paint, Krylon, etc. You spray it on and it coats. And as long as it's not scratched or anything like that, it will protect the metal. But the instant it is scratched, that it no longer protects. Again, here's the galvanized metal. Here are galvanized nails that you would use outside in outside projects. Okay. All right, now in cathodic protection using zinc, again, you still have your water droplet, but as long as you've got a solid zinc surface, then it can't get to the iron to cause the oxidation. The zinc doesn't react as readily, so it'll protect it. Okay, the second type of protection is anodic protection. And the first one you just coated. The second one is that you intentionally corrode it. So on copper, statues, etc., that sit out, they'll pick up a blue-green coating. This is the patina or patina. Sometimes it's caused deliberately. You can do it with acids, etc., if you want it fast, because it in some cases is very, very pretty. Okay. Aluminum, the minute you make it, it's going to make a very, very, very thin oxide layer to protect it. And that's why when you cook with aluminum foil, they always tell you to put the food on the dull side, because the dull side has already oxidized. The shiny side hasn't. They say up and down that they don't put anything on it, but I can't figure out how it's still shiny. Okay, there's got to be something, and I'm assuming it's just oils or whatever from the process. But that's why people tell you to cook on the dull side, because you have intentionally allowed corrosion. Now the third way is cathodic protection. And that's when you put a more reactive metal in contact. We call that reactive metal a sacrificial anode. Magnesium, lithium, and sodium are the most often used because they really, really, really want to act as anodes. They want to lose their electrons. And by doing that, then they force the metal to gain the electrons. So instead of iron going to the rust, then the rust is forced to take up the electrons and go back to the iron. If you've ever seen a display from, the one I'm thinking about I saw in Chicago was the Titanic. If they pull anything up that's majorly corroded, then what they do is they do a slow reverse. It's cathodic protection, but through electrolysis. And so what they're doing is reversing any corrosion that occurred. Now, this is commonly used on ships and in pipelines. So on pipelines, there are pipes that carry water, that carry natural gas to houses, gasoline under the country, all over the place. And the best pipes that'll last are iron, but you have to protect them. So oftentimes you may see little little manholes along an area, and you're like, why? There's nothing there. Well, yeah, what that is it's a pipeline, and they attach their sacrificial anode. And the problem is they have to check the wire, because even if they don't run out of sacrificial anode, if you end up with a break in the wire, then that stops the anodic protection, okay, or cathodic protection. It stops the sacrificial anode. So that's what you'll see for pipes. On ships, you see these little areas right here. Well, what they've got is they unbolt them, put more of the sacrificial anode right in there, and then bolt them back on. And so if you'll notice, they're below the water line, and it works on the entire ship as it goes. Okay. Another issue, and this is not as common anymore now that most fillings are composites and they're not metals. The old fillings used to be mercury and tin combination, and that's why if you've got an old filling and you were eating something and you got a little piece of aluminum foil because it was packaged in on there, and you get a little zap in your mouth, that's because you're getting a redox reaction. And also, this is why it is a problem to get metal piercings in your mouth, because they not only interact with your fillings, but they also interact with the enamel, and some of them will cause the enamel to degrade. And if you haven't heard, you can't replace the enamel in your teeth, so you don't want to lose your enamel. So be very careful about putting any metals in your mouth that aren't required. So we are done with this chapter, and so this will finish the second part of the last test, test 5. We still have exam 6, more about that later.